So how are we going to find these exact values of sine, cosine, and tangent, especially when 0, 30, 45, 60, and 90 are so often what we're looking for, and I can't memorize a chart? Well, I bet you can count to 4. Let's start it with 0. 0 and 1, 2, 3, and 4. That's where we're beginning, right? So of course, starting with sine, and we got 0, 1, 2, 3, 4. Now here comes the crazy part. We're going to take the square root each. Wait a minute, not just take the square root. Take the square root and divide the whole thing by 2. Square root 0 over 2. Square root 1 over 2. Square root 2 over 2. Square root 3 over 2. Square root 4 over 2. Doesn't quite look like your textbook. But if you take a look at the square root of 0 over 2, well, that's just going to be equal to 0. And the square root of 1 over 2, well, that's just going to be equal to 1/2. And the square root of 2 over 2, that's just going to be ugly. And the square root of 3 over 2, also ugly. And square root of 4 over 2, no problem. That's equal to 2 over 2 or 1. Okay, now what about cosine? Cosine doesn't move forwards, it kind of moves backwards. So we're going to start with, here we go. 4, 3, 2, 1, 0. All right, now if this worked out beautiful, we're going to take the square root of each and divide it by 2. So square root of 4 divided by 2, square root of 3 divided by 2, square root of 2 right over 2, square root of 1 over, whoopsie, 2, and square root of 0, haha, over 2. All right, so if I were to simplify these guys, that would give me square root of 4 is 2, 2 over 2 is 1. That's still messy, that's still messy. Oh, I know this one, easy, 1/2, and that one's 0. Now, when I'm thinking about tangent, you know, I could draw a tangent, but I don't want to ever. So I know tangent is equal to sine over cosine. So tangent is equal here to 0 over 1. Easy. Tangent over here, this is kind of a pain. That's fine though, is equal to 1/2 divided by radical 3 over 2. Yeah, that's messy. Call it an algebraic fraction. And deal with that another time. This one's easy because anything divided by itself is just 1. And gross is the other part of the gross one. So we got radical 3 over 2 divided by 1 over 2. Maybe we'll try those fractions later. Right now, let's take care of the last one. Wait, 1 over 0. We can't do 1 over 0. Anything divided by 0 is undefined. So obviously, tangent at 90 is undefined. Okay, that's cool when you're just looking for 0 through 90. But then the other day, or this morning in class, afternoon, we were trying to find other values. So let's think about sine for a minute. Here's my sine, and it goes up, down, and up. That's the positive sign, all the way from 0 to 2 pi. And it's not drawn perfect because I'm in my kitchen. But you know what? If I wanted to, I can look at the other side too, the negatives of sine. So let me just, you know, down, up, and over. And just so I know what's going on here, I'm going to label everything. This guy would be my pi. This guy my 2 pi. And if you remember in class, we took this and we chopped it up into like important spots. Important spots are going to be one of the key terms of like this whole course. And they're not always going to be called important spots, but for right now, that's perfect. So 0 was an important spot. Then in between pi and 0, we had this one over here. Pi over 2, because it was halfway in between. Then this one over here between a whole pi and 2 pi is another important spot. It's 1.5 pi, but you know, fancy calculus, gotta use fractions. 3 pi over 2. Now those are the big ones, positive ones. Let's take a look at what happened on the other side. Again, we're gonna chop this in half down over here, but I'm gonna be careful because this is not, it's not regular pi, duh, it's negative pi, and it's not regular 2 pi, it's negative 2 pi, close catch. So this mama jama, that spot, that important part, or critical value, you didn't hear me say that, is at negative pi over 2. This one is negative pi, and in between here, well, it's between a -1 and -2, so it's got to be -1.5. But again, we're fancy, so we're using fractions all the time. Okay, now that's cool. That tells me the fancy pi measure of all these spots on sine, but how does it relate to this, right? I'll tell you how it relates to this. Pi is 180 degrees. So the exact value, and now I don't care about much else, but if it's a positive or negative right now. So the exact value of sine of 30, that's over here somewhere. It's positive. But let's say that I'm not looking for sine of 30. Let me make my chart bigger. Sorry, undefined, you're getting erased. Let's see. From 0 to 30 would be 30, so let's take it from 90 to 120. Just one more little spot. I tried to draw the whole chart in my kitchen and realized that would be stupid. So at least one more little spot. And let's see what happens to sine at 120. Oh, well, not much. It's still right over here. Wait a minute, but it's right over there. It's a little bit lower. The number, the y value, is a little bit lower than it was. So if the y value was 1 before, you know what? I bet you we're just kind of like moving backwards. Because look, here we're going up on the, and then we're going down. This is it. Holy smacks, ready? So if we had 1 before, now this one would be root 3 over 2. Ha, cool. Well, what about if we went further? I guess we take another step back and go root 2 over 2, and another step back and we go 1/2, another step back and we go 0, and let me match up the degree measure because this is kind of cool. 1, 2, 3. Sorry, my writing sucks. From 120, the next thing that we did was 15 more. That would be 135 degrees. Still a positive, but not as much of a positive. At 1/2, well, that would be 150, because it's, check it, 60 more than 0 and 60 more than 90, 150. That's giving me my half. And 180, well, that's got to be the next spot. 180 has got to be 0. And just to make sure I'm looking at the picture. All right, so here I was at 0 pi's. Here's a 90 degrees, or 1 pi over 2. Here's, 180 at 0. But check out what happens after that. We're going negative. So if I want to make this chart even further, like to go to the next spot, or 210 degrees, I'm pretty sure that we're just going to be going the same pattern in the opposite direction. I think it'd have to be negative 1/2. So 210 degrees, if the sine of 210 degrees equals negative 1/2, then I never have to memorize anything except how to count from 0 to 4 and backwards from 4 to 0 ever again. Okay, I'm gonna go check on my calculator. I was gonna graph you cosine so we could also look at the positives and negatives, and the positives and negatives, where the degrees are, or the exact value would be positive, and then after, or down here where they'd be negative. Yikes, that happens sooner too, because if you remember, that's pi, and this is pi 1/2, or pi over 2. Well, we can talk about that later. Hope you enjoyed my silly, way too long video. I'm going to put it up on your Google Classroom, and it's 9 minutes of pain, so you never have to memorize that chart again. Whew. Have a good night.